In this video, we're going to be discussing how we add and subtract rational expressions together. The first section, 8.3, specifically deals with the adding of rational expressions, and 8.4 deals with subtracting of rational expressions. I'm trying to combine those into one single unit, one single lecture, as I feel like it's a bit more useful to see all of this together because nothing really changes between addition and subtraction in our general processes. So a big thing I want to note as we're getting started with this, rational expressions, as a reminder, are pretty much just fractions. So remember, as we're going through all of this, we are going to be adding, subtracting rational expressions with the same general idea of adding and subtracting fractions together. And what I mean by fractions is something like 1/2 plus 1/3, or 2/3 plus 3/4, or 5/7 minus 1/6, something like that. So all of our previously learned rules for adding and subtracting fractions together, we are going to still be using those, and those rules still apply here, but we now have a bit more complex and admittedly grosser looking expressions and fractions that we are working with. So we have two scenarios showing up here with these problems. We have instances where we have common denominators and we have different denominators. Now the processes for each are fairly similar. The only difference is a couple setup steps depending on if I'm starting with the same denominator or with different denominators. So let's assume we have the instance of we have common denominators here. We have our process written here. Again, I'd recommend, as necessary, pause the video and get these steps written down for yourself. The first thing that we're going to do, or at the very least this is step 0, something I like to throw in with these, an optional first step. You are eventually going to have to do this step. The choice is whether you want to do this at the very beginning of the problem or later on throughout the problem. What our first optional step entails is to fully factor all of the denominators specifically. You can use any and all the previously learned methods for factoring to make that happen. So now that we have everything with the same denominator, since that's what we've been given, we are going to add or subtract the numerators together to create a single rational expression. We could have 2 expressions, 3 expressions, 4 expressions all adding together. Everything is all spaced out and everything like that. Let's kind of smush it all together and make one single rational expression that we're going to work with. That's the intention behind our first official step here. It should be noted, similarly, when adding and subtracting regular fractions, we are going to leave the denominators fully factored, and the denominators are not going to change in the addition-subtraction step through this overall process. So now that we have everything as one single fraction, our second step is to simplify the numerator. This includes distributing things, combining like terms, and all of that. We are going to have a brand new numerator for our rational expression, and we want to make that thing as simplified as we possibly can. Combining all like terms, using the distributive property as necessary, those are just a couple of things that generally tend to show up in this part of our overall process. The last thing we need to do, which is kind of going back to what we did in 8.1, but we are going to be simplifying or reducing this new rational expression down. The way we do that is we are going to need to fully factor the numerator and the denominator and then cancel things out accordingly. So as mentioned at the very start of this process, step 0, fully factor all the denominators, you are eventually going to have to do that at the very end of the problem. The choice is whether you want to do that factoring at the very beginning, where it can be helpful, or at the very end where you have no choice and you absolutely must do that. So just want to note that is where this step 0 is linking in with what we're doing here at the very end of the problem. Now it should be noted, similar to what was talked about in section 8.1, when we are simplifying and reducing things down, we need to factor and then cancel. Factor the numerator and the denominator, then cancel things out accordingly. If you cannot factor anything, then you cannot cancel anything. The rule of how mathematics works with these rational expressions. So moving on to our arguably trickier but more common scenario where we have different denominators, this is where we have to do some setup work for ourselves. So our process we have written out here, again, I'd recommend, if necessary, pausing the video and writing these steps down for yourselves. There are a couple hints in here which we'll go through and we'll see an example of as well. But our first step is to fully factor the denominator of all rational expressions in every single thing that's written in the problem. You could have two things adding or subtracting together. We could have three things adding or subtracting together, four things, five things, doesn't matter. We need to fully factor the denominator of all rational expressions. Just start off with doing that. It's a great starting point for all of these problems. If you would like to factor the numerator, you can. I do not think it is necessarily a required step though. So if you are wondering whether you should or shouldn't do it, please make a note that factoring the numerator is optional. And if you're unsure, I would default to leaving the numerator as it is. We'll deal with it later. Now in this step, I do want to note that in some instances, in our fully factoring of the denominator, we may need to sometimes factor out a -1 to do a small change to the denominator. And that's going to come into play with our second step. But sometimes just a -1, which just flips the signs of things, is something that's necessary in these problems. And we'll see an example of that showing up here shortly. In step 2, we need to determine the lowest common denominator amongst all rational expressions. Think back to when we were just adding or subtracting basic fractions together. We need to make sure the denominators are the exact same, or we have these common denominators. That's the only way I can add and subtract fractions together. That's the only way I can add and subtract rational expressions together. So we go through and determine what's the lowest common denominator between every single rational expression in this given problem. Once we have that determined, and I'll show you how we do that, and I would recommend making notes of that and writing that down somewhere near the problem for yourself, we are then going to rewrite each rational expression to have that lowest common denominator. This is again similar to what we've done with our adding and subtracting of previously done problems, or just standard quote-unquote easier fractions. When we are doing this, this means we are going to need to multiply the numerator and the denominator of each rational expression by something. That will vary based on the problem, based on what's been given to you, and based on what the lowest common denominator is. We'll see plenty of examples of this showing up here with some examples. So once we have everything written out with common denominators, you can notice that steps 4, 5, and 6 in this process are pretty much the exact same as 1, 2, and 3 in our other process. And that's the case because now we're just combining everything together. I will note that unique to this one, kind of a hint that I would give you, when you are doing the adding and subtracting phase where we are getting everything to be one single rational expression, I would highly recommend that in that process you leave the denominator fully factored. Looking ahead a couple steps, we are once again going to need to simplify that new rational expression down, which means we are eventually going to have to fully factor the numerator and the denominator. So if you choose in step 4 to multiply all the denominators out while you are adding and subtracting the numerators, you can do that. But I am warning you now, you are going to need to fully factor that out again at the very end of the problem. So I'd recommend not doing that sooner, only because you're going to have to undo what you just did eventually. And it's just creating more work for yourself. So that's our general process that we have for our two setups with rational expressions. Again, I would recommend pausing the video and writing these down for yourself as necessary because we will be referencing them with our examples. But otherwise, let's move on to some examples that we have here and get looking at these things. Here we have our first example of adding and subtracting rational expressions together. Now I'm looking at this thing, and from the beginning I'm checking to see, are the denominators the same or different? Because that's going to determine which process I am going to follow. I'm seeing here that the denominators are the same, so I can follow the first process that was listed, the instance where I have common denominators. Our step 0 says to fully factor all denominators. Well, I can't exactly factor v plus 5 at all in either of these situations, so that's fine. Step 0 is done. Our first step says to add and subtract the numerators together to create a single rational expression, effectively making it, instead of two things, combine it together to be a single one. Now, my recommendation when we are doing this is to write out a decently sized fraction bar for yourself. Remember, the denominator does not change, so I'm just going to bring that down now. And then my recommendation is each individual numerator, whether it be a monomial like we have in this scenario here, or a binomial, kind of looking similar to where our denominator is, I would always recommend putting every single numerator inside of a set of parentheses. The adding and subtracting just comes down exactly as it was. No changes there. And now we have everything written as one single fraction, not two separate ones. The reason I recommend that we write everything inside of parentheses is going to become apparent in some of our future examples where positive or negative signs might need to distribute through to multiple terms inside of a set of parentheses. It's not happening here, but that will be showing up in future examples. Oops, there we go. So now that I have everything written out as one single rational expression, our second step is to simplify the numerator. We're going to use distributing. We're going to be combining like terms anywhere we can. So I'm looking at this and saying, okay, well, I've got parentheses. Can I simplify or have any distribution going on? Well, nothing's going to change there. I can't do anything to simplify this 30v down, so that's fine. If nothing else, I'm going to rewrite my numerator just without a set of parentheses. I can't combine any like terms in the numerator spot. That's fine, but I'm just rewriting it a little bit for myself. There's nothing wrong with taking steps to rewrite problems. If you need to do that, please do. A lot of people try and skip steps or do it in their head, and I tend to find that's where errors show up. So let's avoid those if we can. So our last step says to simplify or reduce the new rational expression. I want to really emphasize the idea that it's a new rational expression because I have a brand new numerator now. So if I want to simplify this thing, I need to fully factor the numerator and the denominator. So I fully factor the numerator. I'm looking to see, is there a greatest common factor, because I always start factoring that way. There is. It's 6v. So I can factor out 6v from the numerator. And what's left over is v plus 5. And now we notice I have a v plus 5 up top and a v plus 5 down below. I have fully factored everything, which means now I can look to cancel things. And I'm noticing I have a v plus 5 up top and a v plus 5 down below. Those can divide out each other. They cancel out. Each of them becomes 1. I'm just going to rewrite this top here because I'm running out of space. And what's my new numerator? Well, it's going to be 6v times 1, which is just 6v. My entire denominator became 1, which means I don't need to explicitly write that in. It is assumed to be there. And from here, everything I have left is just 6v. I cannot factor that at all. I cannot cancel that with anything else. And I have my final answer. For our second example, we again begin by looking at the denominators and seeing if these things are the same or different. And looking at them at face value, these things are going to be different from one another. So, our first step in that process would be to fully factor the denominator of all rational expressions. I don't need to factor the numerators because that's optional. So I'm looking at this and wondering, well, I can't really factor anything out of 5w minus 2. Nothing I can really do there. And similarly with the second one, I can't really factor out anything from 2 minus 5w at all. So this might look like something at face value where I can't factor this thing and therefore I can't go any further with this problem. but that's actually not the case here. Let's take a look at these parts of the denominator in a bit more detail. I have a 5w and a 5w in both of them. I'm noticing that the first one is a positive, second one is a negative. So it's the exact same, but opposite signs. I'm noticing that they both also have a 2 in there. In one instance, one is negative, in one instance, one is positive. So when looking at these, I'm noticing that these denominators are the negative of one another. So that means, using the hint that was listed in the process, I can factor out a -1 from one of these denominators, and that will change the sign of that one denominator, creating an overall rational expression, or two rational expressions, I should say, with the same denominator. Now, I am electing to factor a -1 out of the second rational expression, just because I like to have the leading term be my variable term. So nothing's happening with the first one. I'm going to factor out a -1 from the denominator of the second polynomial. So I factor a negative out. What's going to happen with that? All that means is each of these signs are going to change. That -5w is going to become a positive 5w, and that positive 2 is going to become a -2 here. Nothing's changing with the numerator yet. We're not doing anything with that in this step, so I'm just bringing that down as it is. So now I'm noticing and looking at the scene, well, the denominators look like they're closer to being the same, but I have this minus sign out front of the second denominator. Well, we can deal with that by saying and noticing I have a positive divided by a negative. What's that going to give me? That's going to give me a negative overall expression. So that means I can rewrite this sign into, instead of being a positive number or a positive sign, I can switch it to a subtraction sign. So we'll do another rewrite. And now I can more explicitly see that instead of adding a negative, I'm just going to be subtracting something. We simplify those signs down. And what's also nice about this is now I have two rational expressions with the exact same denominator. So now I could refer back to the common denominator process. We're going to continue on with our different denominators process that we had there, the 6-step one. So our second step would be to determine the lowest common denominator amongst all rational expressions. Well, it turns out in this process that already happened, so good to go. Rewrite each rational expression to have the lowest common denominator. Again, we don't need to do that. We already have a common denominator. I'm now going to add and subtract the numerators together to create a new single rational expression. So let's write that out here. I'm noting the hint with this as well. Leave the denominator fully factored. I think it's pretty good practice to start off with just writing off the denominator for ourselves there. Again, the denominator is not changing. Again, for me personally, I like writing, and I recommend writing each individual numerator inside of a set of parentheses. Any addition or subtraction that could be showing up between different expressions is just going to fall down exactly as it was. So now, looking at step 5, we're told to simplify the numerator. We're doing any distribution, we're combining like terms, all of that. So I'm going to rewrite this and move us up here because I'm running out of space. And this could take a couple lines of work to do. There's nothing wrong with that, but you want to make sure that you are fully simplifying everything down. So I'm looking at this and noticing that this negative is going to have to distribute through to everything in that second set of parentheses. So I'm going to get -5w minus 6 showing up. Again, the denominator does not change. That's not written into the process, so we're not doing anything with it. I can further simplify the numerator by combining like terms. I have 20w minus 5w. That's going to give me 15w minus 6. And again, the denominator doesn't change. I'm then looking to see, can I combine anything else in the numerator? Can I simplify anything else in the numerator? And no, I can't. So step 5 is done. Step 6 then says to simplify and reduce the rational expression down. Fully factor the numerator or denominator and cancel things out. So again, we need to remember, I need to factor, then cancel. Factor, then cancel. So can I factor the numerator at all? Turns out I can. I can factor a 3 out from the numerator. Oops, it's not minus 6. Should probably be writing the right thing in here. There we go. So I factor a 3 out. I'm going to have 5w minus 2 left over. I can't factor the numerator any further. I also can't factor the denominator any further. So now, because I have fully factored everything, now I can look to see, can I cancel anything? And I can. I'm noticing I have a 5w minus 2 in the numerator and the denominator spot. Those cancel out and they each become 1s. And what's the only thing left over? Just a nice little 3. And we can't cancel or simplify or reduce that down any further. So, our final answer for example problem number 2 is just going to be the number 3. Moving on to example 3, we are starting with 5 over 6a squared b plus 1 over 4a. So I have different denominators here, so I'm going to be using the second process, that 1 through 6 process. Our first step says to fully factor the denominator of all rational expressions. The denominators are monomials. There's only one term down there. So I cannot actually factor these denominators at all. They're just going to have to stay exactly as they are, and that's okay. Step 2 says to determine the lowest common denominator amongst all rational expressions. Now my recommendation is somewhere nearby, write out for yourself LCD. We are going to log what that lowest common denominator is because we will be using that in our future steps. So we're going to determine the lowest common denominator just like we would with all of our previous methods that we had with finding the lowest common denominator of fractions. I'm looking at the denominator and seeing that I have a 6, or say numbers, a's, and b's. So I'm going to deal with those one at a time. Looking at the numbers, 6 and 4, what's the lowest common denominator, or the lowest common multiple of 6 and 4? That's going to be 12. The smallest number that 6 and 4 can both evenly multiply into. Then I go to the a's. Between a squared and a, what's the smallest thing that they can both multiply into? Well, that's going to be a squared. And then looking at the b's, I have a b in the first one and I have no b in the second one. So the smallest thing they can both multiply into is going to be a b. Now I have seen some people choose b, they'll put an invisible 1 here to represent that b. If you'd like to do that, you can. I would advise a little bit of caution with writing more things into the denominator spot than necessary, but if it helps you get to that lowest common denominator, then that works fine. So we have our lowest common denominator here. Step 2 is done. Moving on to step 3, we're going to rewrite each rational expression to have the lowest common denominator. So this means we're going to need to multiply the numerator and the denominator of each original fraction by something to create that lowest common denominator. So I find it helpful to write it out with some parentheses here. I'm looking at the first fraction. I'm saying, what do I need to multiply 6a squared b by to get 12a squared b in that denominator spot? Well, the 6 just needs to be multiplied by 2. The a squared is already the same. The b is already the same, so I don't need to do anything else. So I just need to multiply this denominator by 2. Now to create an equivalent rational expression, if I'm going to multiply the denominator by 2, I need to also multiply the numerator by 2 as well. I'm required to do this because if I don't, then I have fundamentally created a brand new rational expression, and I have fundamentally altered the very nature of the problem that I am working with. We don't want that. let's take a look at our second rational expression. And again, I think doing this numbers, first variable, second variable, third variable, and so on makes this a little bit easier to manage. 4 times what is going to give me 12? It's going to be 3. A times what gives me a squared? That's going to be a. And then 1 times what gives me b, which is going to be b. And now I have everything I need to make the denominator that 12a squared b. So I'm multiplying the denominator by 3ab, which means I need to also multiply the numerator by 3ab. And now I can rewrite each of these things out, multiplying everything together. My first expression is going to be 10 over 12a squared b plus 3ab over 12a squared b. We're just multiplying straight across. And now we have everything rewritten with that lowest common denominator. On to step 4, we are going to add and subtract the numerators together to create a new single rational expression. And again, for me personally, I really like writing each numerator inside a set of parentheses. Makes it really clear to me what are the 2 things I'm adding together, or 3 things I'm adding together, or so on. Okay, so there's step 4. Step 5 says to simplify the numerator. Well, I can't really do any simplification with the numerator specifically. I can't add or subtract anything together. There's no distribution that's happening. I've got a variable term and a constant term, so those things are going to need to stay separated. So I'm just going to do a small rewrite. Actually, I'll move this up here because I'm running out of space. And I'm going to get a new numerator of 10 plus 3ab over 12a squared b. Didn't really change a whole lot. I just dropped the fractions, or not the fractions, the parentheses, I should say. That's all right. Good there. Our last step, simplify/reduce the rational expression. Remember, we need to factor before we cancel. I have seen a lot of people look at the 10 and the 12 and say, well, I could reduce both of those by 2. Or I have a 3 here and a 12 here. I could reduce those down by 3. And I have an a here and an a squared here, so those can reduce, and the 2 b's are going to cancel, so then we start canceling things out at random there. Rule of thumb, I'd write this down for yourself, factor, then cancel. If you cannot factor anything, which is the instance we have here, then you cannot cancel anything. And this leaves us with maybe a slightly disappointing answer in the fact of, well, I can't cancel anything. I can't make it a little bit simpler. Yeah, that's just kind of how it is. But that's fine. So because I can't factor anything, my final answer is going to therefore be 10 plus 3ab, all divided by 12a squared b. And again, it comes back to this rule. We have to factor first and then cancel. We can never pick and choose what to cancel from the numerator and the denominator without factoring first. So now we move on to our 4th example. Our 4th, 5th, and 6th examples are where these start to get a little bit more intensive with the work and the number of steps that are going to be taken. So make sure you are doing these very slowly, very deliberately, and you're keeping track of everything that's going on in these problems. So at start of number 4, I'm noticing that I have different denominators. So I'm going to need to change that before I can add these things together. Our first step is to fully factor the denominator of all rational expressions. Well, z minus 2 is fully factored, z plus 5 is fully factored, so the first step is done. Awesome. Second step, determine the lowest common denominator among all rational expressions. I'm going to make a note off to the side for myself what that lowest common denominator is going to be. Now the first rational expression has a z minus 2 in it. The second one doesn't, and I'm noticing kind of the inverse of that. The second one has a z plus 5 in it. The first one is missing that. So the lowest common denominator is going to need to include both of these binomials. And what's nice about when I have binomials in the denominator spot is our lowest common denominator basically becomes those binomials multiplying together. So now I have step 2 done. There's my lowest common denominator. Step 3 says to rewrite each rational expression to have the lowest common denominator. So like we did with number 3, I think it's very, very useful to write out for yourself what is the first rational expression. Now what am I going to multiply that by in the numerator and the denominator spot to get my lowest common denominator here? Well, the first one already has a z minus 2. It needs a z plus 5, so I'm going to need to multiply that by z plus 5. And if I'm doing that to the denominator, I need to do that to the numerator as well. Makes it an equivalent fraction. With the second expression, the denominator already has a z plus 5. It's missing a z minus 2, which means I'm going to need to multiply this denominator by z minus 2 to make that happen. If I multiply the denominator by z minus 2, then the numerator is going to also have to multiply by z minus 2. So I've set that up for myself. I know what I'm multiplying out. Now I can actually multiply these things together. Let's see what it looks like. Our new numerator, the first part, is going to be 3z times z plus 5. And the denominator is going to be z minus 2 times z plus 5. The second one is going to become z minus 2, and the denominator is z plus 5 times z minus 2. Now if you're looking at this and noticing, well, the denominators are the same, but they're in different orders, and one of them doesn't exactly match up with the lowest common denominator. As long as everything is multiplying together, the order of that multiplication doesn't matter. You can think of the quick example of what is 2 times 3, and is that the same as saying 3 times 2, where you just reverse the numbers in multiplication. That's the same instance we have showing up here. So now, step 4 would tell us we need to add or subtract the numerators together to create a new single rational expression. I'm going to do one slight rewrite before I do that. I'm looking at the first numerator and I'm noting I could multiply that 3z and the z plus 5 together. I'm going to simplify that down now when I have everything separated out before I make it one big rational expression and I might lose track of things along the way. This is a personal preference step of a rewrite. You do not have to do it, but I think it's easier to do these things in smaller, more controlled parts if necessary. Or as necessary, I should say. Oops. There we go. And nothing's changing with the second rational expression. So I'm just rewriting that exactly as it was. And now I'm following step 4 of adding and subtracting the numerators together to create a single rational expression. So I'm going to move us up here for that step. And if you're noticing that these problems are getting longer and more complex, yeah, that's kind of the nature of them. There's a lot of steps, there's a lot of things going on. So take it very slowly and very deliberately as necessary. Again, as the hint recommends, in step 4, leave the denominator fully factored. We are going to need to multiply that thing together, or we're going to need to, I should say, we're going to need to factor that thing again, or factor that anyway. So if you were to multiply all of that together and do distribution, you're going to have to break it down into this form again later on, so you can just leave it exactly as it is. And it should be noted that essentially from this step here, the denominator isn't changing. We're just leaving it, which is nice. Less work we have to do. So now, step 4 said to add and subtract numerators together. We have a new single rational expression. Let's simplify that numerator as best we possibly can. Meaning, I'm just going to be doing the distributive property. I'm going to be combining like terms all in the numerator spot. Again, I'm ignoring the denominator. I'm just leaving it fully factored. Nothing is happening with it yet. Simplifying the numerator. So I have 3z squared plus 15z. This plus sign here isn't going to change the signs of this second set of parentheses. So I have 15z plus z minus 2. So the 15z and the z can combine together. That's going to give me 16z. The minus 2 at the very end, there's nothing else that combines with that. It's just a constant, so it's just going to hang out there as it normally would. So now I have a fully simplified, brand new numerator. Make sure you are doing that before you are fully factoring things out in the numerator and the denominator spot, which is what we're going to do next. Step 6 says to simplify or reduce the rational expression. The only way I can reduce or cancel things out is to fully factor the numerator, fully factor the denominator, and then I check to see if I can cancel things. I can absolutely never pick and choose what to cancel if I have not factored first. So I'm looking at the numerator here. There's no greatest common factor, so I might have to use the AC method here. So I'm just going to write that down below. My A value would be 3, my B value would be 16, my C value would be negative 2. A times C is going to give me negative 6, because that's 3 times 2, negative 2. And now I need two numbers that multiply to negative 6, then add together to be a positive 16. I'm noticing, okay, that's going to be a positive and negative there. I'm not seeing any numbers that multiply to negative 6, we have here, and add together to be 16, which means I cannot factor this numerator. That's fine. Just how the numbers work. So because I can't factor the numerator, I can't cancel anything, which means that this problem at this point in time is now done. Again, we like to cancel things out if we possibly can, and we always have to check for that. But again, that requires that we need to factor first, and then we can cancel. If we can't factor, you can never cancel anything out then. Looking at example 6, we once again have two different denominators showing up here. So we're going to use the different denominators process. Step 1 says to fully factor the denominator of all rational expressions. So factoring the first denominator, looking at this and I'm noticing, well, there's no larger number here. So I now just need to find two numbers that multiply to negative 10 and add together to be negative 3. And those numbers are going to be negative 5 and positive 2. So our first denominator, fully factored. Taking a look at our second rational expression, fully factoring the denominator. I need two numbers that multiply to be positive 15 and add together to be negative 8. And those numbers are going to be minus 5 and minus 3. So our first step is done. Moving on to our second step. Determine the lowest common denominator among all rational expressions. So again, I'm going to make a note for myself somewhere. I'm going to write at the very top here. What's my lowest common denominator going to be? Well, I notice that they both have an x minus 5 in them, so I am going to have to include that. They have that in common. The first one has an x plus 2 in it, which means that the second one is going to eventually need that. And the second one has an x minus 3 in it, which means the first expression is going to need that. And again, if I have binomials showing up down here, kind of noticing that You can kind of multiply everything, all those binomials together, and that's going to end up giving us our lowest common denominator, which is kind of nice here. So now, step 2 being done, I'm moving on to step 3, rewrite each rational expression to have the lowest common denominator. So looking at, oops, some space here. So looking at, it's a minus 5. Should probably write the right thing in. So looking at the first rational expression, what does that need to be multiplied by so the denominator is the same as this full lowest common denominator up here? Well, all it's missing is an x minus 3. I'm just going to write that in. If I multiply the denominator by that, I need to multiply the numerator by that as well. I just want to apparently make everything plus with this. So make sure you're writing things out properly. And then we're applying the same thinking with the second rational expression. What does it need to be multiplied by so the denominator down here is the same as this lowest common denominator? And we're seeing that it's missing an x plus 2. So that means the numerator and the denominator of the second rational expression is going to be multiplied by x plus 2. Now I can multiply all of that together. The new denominator of the first one is going to be x minus 5, x plus 2, x minus 3, all multiplying together. The new numerator is going to be 6x minus 18. That's the 6 distributing through to everything inside that set of parentheses, and we get this answer here. Now I'm adding that with, our second one, and I'm just going to start with writing the numerator, or the denominator out, I should say. And then the new numerator is going to be 5 times x plus 2, so that distributes through. I'm getting 5x plus 10. And now I'm combining everything together to be one single rational expression. I'm going to move us down here just for one final line, then I'll rewrite it up above. The denominators are the same, so I can rewrite everything as one single rational expression. That's step 4, where we're adding and subtracting the numerators together. Remember, in this step, leave the denominator fully factored. If you decide to multiply this denominator out, I'm going to warn you now, you're going to get something raised to the third power, and we will not be covering how to factor something raised to the third power. So you can leave the denominator factored, and you're not going to touch it until you cancel things out at the very end, if that's possible. So the first numerator, again, I always like to write these things inside of sets of parentheses. Whoop, also noticing a typo that I have in here. I had a 5, I was missing a 5x from above here, so this thing needs to get rewritten. Apologies there. So our new numerator for the second one should be 5x squared plus 10x. There we go. And there we have our new, everything written together as one single one. Now it's all correct. Just went back and double checked my work there, and yay, mistakes happening. So now I have everything written as one single rational expression. Step 5 says to simplify the numerator down. I'm doing the distributive property. I'm combining like terms where I can. So let's go through and make that happen. I'm going to rewrite the simplified portion up here. Oops. There we go. Again, our denominator is going to stay fully factored, so I'm changing nothing with that. Because I'm changing nothing with the denominator, I find that to be a great starting place from one line to the next. Now looking at the numerator, I can't really combine anything with the x squared, so I'm just going to have 5x squared showing up still. I have 6x plus 10x, which is going to give me 16x. Then I have a minus 18 at the very end, just a constant term, so nothing's going to be adding on with that. Okay, and now I have my new numerator written out there. And my last step, in step 6, it says to simplify or reduce the new rational expression down. Fully factor the numerator and denominator and cancel. So I'm looking at the numerator, I'm saying, well, can I factor that thing? There's no greatest common factor between 5, 16, and 18, so I'm going to have to use the AC method. My A is 5, B is 16, C is negative 18. Now I'm grabbing a calculator here, and I'm seeing for myself, what is 5 times negative 18? It's going to tell me that A times C is going to be negative 90. So now I need to find two numbers that multiply to be negative 90 and add together to be positive 16. So again, I'm doing this calculation off to the side using a graphing calculator. I'm going to list the factor pairs of 90. 1 and 90, 2 and 45, 3 and 30, 5 and 18, 6 and 15, and then 9 times 10. Next would be 10, so I'm done there. And let's see, so we have positive and negative there. All right, so what two numbers when added together, or what pairing of numbers when added together gives me a positive 16? And I'm not saying that any combination of numbers listed here with their respective signs at the bottom are going to add together to be a positive 16. That tells me that I cannot factor this numerator, this brand new numerator that I've been given it all. So if I cannot factor the numerator, then that means that I cannot cancel anything in the numerator with anything in the denominator, which means if I can't do that, I am therefore done with this problem. I can't multiply anything else out. I can't combine any other like terms. I can't simplify it down. This is the absolute best I can do, and I therefore have my final answer. So we're now looking at our final example here of adding and subtracting rational expressions. Now I have three things showing up here that I'm adding or subtracting together. Our process is going to be the same. We're just going to end up having to do more steps involved with it. Doesn't necessarily mean that our steps are going to be changing, just means we're doing more of them. So our first step in our process with different denominators, fully factor the denominator of all rational expressions. First denominator, fully factored. Second denominator, it's a monomial, so it's fully factored. Third denominator, there's a common denominator, or a common multiple, I should say, a greatest common factor between 2b squared and 10b. I can factor out a 2b from both of those terms. So the first rational expression is not changing, so I'm just bringing that down as it is. The second one is not changing either, so it's just coming down exactly as it is. And the last one, I am factoring out 2b from the denominator spot. What's left over? b minus 5. Numerator is not changing, that's fine. Leaving that as it is. So step 1, done. Step 2, determine the lowest common denominator among all rational expressions. So again, I'm making a note of that somewhere on the page for myself. I find a lot of people that do not write this out somewhere on their paper tend to lose track of what the lowest common denominator is and tend to lose points with these types of problems. So I'm looking at all my denominators that I have here. I'm seeing what would be the lowest common one that they could all have. Well, this one has a 2b in it, which means that's going to need to be included because it's a monomial. I'm noticing that this first one has a b minus 5, and the third one also has a b minus 5 in it. So that's going to also need to be included. All right, and well, it's looking like this lowest common denominator is in that third expression, the first one has part of it, the second one has another part of it, so I'm just going to need to rewrite each of them individually and differently to get to this lowest common denominator here. And again, that's our step 3. Rewrite each rational expression to have the lowest common denominator. So for our first one, what does it need to have this lowest common denominator? Well, it's missing this 2b, so that means I'm going to need to multiply it by 2b in the denominator and 2b in the numerator spot. Looking at the second one, I have 3 over 2b. And what is it missing to be the same as this lowest common denominator? It needs that b minus 5. So I need to multiply the denominator by b minus 5, and therefore the numerator by b minus 5. And this last one that we have, oops, should probably just write a, there we go, subtraction sign. This last one is already written to be that lowest common denominator. So nothing needs to change with that last rational expression. So I'm just bringing it down exactly as it is. Nothing changing at all. There we go. So now I'm going to simplify each of these other two down, at least the numerators. So these things are rewritten, again, to have the same lowest common denominator. So 2b times 2b, that's going to give me 4b squared. And then the denominator spot, remember, you can leave the denominators fully factored. If you would like to multiply them together, you can, but you are going to have to factor them later on. So I'd recommend not doing that and saving yourself a little bit of extra work. And what's nice about this then is we can pretty much just write out the denominator as the lowest common denominator right from the beginning. So my numerator for the second expression, that's going to be 3b minus 15. Nothing happened with the last one. So I'm just bringing that down exactly as it is. Nothing's changing there. I'm now moving on to step 4. We are going to add or subtract the numerators together to create a new single rational expression. So we're going to have one big thing written out here. Give myself some space. And again, I like to put every single numerator inside of a set of parentheses. We're going to see that show up and why we need that with this minus sign here in a second. We have our new numerator all written out. The denominator is staying the same, and it is staying fully factored. Oops, it's just 5 down there. Okay, I'm moving us up to the top here. Try and keep it all on the same page here. I'm now moving on to step 5. I'm going to simplify the numerator. Again, I'm leaving the denominator factored. I don't care what that is. I'm going to eventually have to factor it anyway, so just letting that stay as it is. Now the new numerator, I have nothing in front of this 4b squared that distributes through to it, so it's just going to stay as 4b squared. This 3b minus 15, well, it's got a plus in front of it, but that's not going to change anything, so it's just going to come down as it is. So it's going to be 3b minus 15. And with this last one, I have a minus in front of the set of parentheses here, which means this negative sign is going to need to distribute through to everything inside the parentheses. So my new simplified part here is going to be minus 2b plus 15. So everything is distributed out, and now I'm going to combine like terms together where I possibly can in the numerator only. So I have a 4b squared. I don't have any other b squared showing up, so I can't do anything with that. I have 3b minus 2b. That's going to give me plus b there. And then I have a minus 15 plus 15. Well, those are going to cancel out. and I don't have anything else showing up in that denominators, or that numerator spot, I should say. So I can actually make this thing a little bit smaller here. And then just have my denominator of 2b times b minus 5. Okay, so there's our step 5. We fully simplified the numerator as much as we possibly can. Step 6, final step, simplify and reduce the rational expression. Fully factor the numerator and denominator and then cancel. So again, if I want to cancel things, I need to factor, then cancel. So looking at the numerator, I can factor a b out from both of those terms. I have a 4b plus 1 left over. The denominator is already fully factored, so don't need to do anything with that, which is great. Again, saving ourselves some work. I can't factor the numerator any further. I can't factor the denominator any further, so now I can cancel things out. I have a b in the numerator spot. I have a b in the denominator spot. So each of those cancels. They become 1. And my brand new numerator is going to be 4b plus 1. My denominator is going to be 2 times b minus 5. And I can't cancel anything else out, so I can leave this as my fully reduced final answer. And I'm good to go from here. It should be noted, as showing up with some of these other examples, and we have it here, you are welcome to leave your denominators in fully factored forms. You can and sometimes will see the final answer with the denominator having everything multiplied together, but that's not necessarily a requirement. Leaving the denominator fully factored is perfectly acceptable to go through and use as you're going through these problems. And it saves you some steps at the very end, like we have here, because now we're done. So bringing us back to our overall notes, and I recommend if you have not done so, I would write out the processes that we have for working with adding and subtracting rational expressions if we have common denominators or if we have different denominators. The problems that we worked through and their answers are listed right below here as well. And we also have some additional practice problems if you would like to give these a try. Try and zoom this in here a little bit. Center it. There we go. But the big thing I want to emphasize and really make sure that we're also taking note of with these types of problems, these get long, they get complex, and there's a lot that's going on with them. So make sure you are showing your work and showing your steps as necessary. Do not skip steps. Go as slow as you need and write out as many lines of work if it will help you keep your work organized as you're going through these problems. We'll scroll down here for the final answers for each of these. Got those there. So this is everything for the 8.3 and 8.4 material about how to add and subtract rational expressions together.